All right. Good afternoon, everybody.
Good afternoon.
We are really pleased to be here to talk about make the robotics smarter, safer, and affordable with the semiconductors to enable the functions. Today, I'm William. I'm responsible for Taiwan sales and applications as a general manager in Taiwan. Today, I will spend the first 10 minutes to talk about overall TI, high-level TI overview, as well as what we are doing right now this year and how we enable the next decade to come. And we'll have the remaining of 20 minutes to introduce you our expert, Matthias, to further talk about the robotics trend and what we are working on with that technology development. So last year, TI ran 20 billion revenue, mainly from analog and embedded products. And we continue investing in the future, both from capacity expansion and also the product technology expansion as well. So we spent 8% of our revenue for R&D investment. We spent another 14% of our revenue into capital expenditure to enable the future. We feel pretty good at the mix of the business we have today, and we love the diversity of the market with our broad portfolio, as you know, from analog and embedded products. Especially, we are excited with industrial, automotive, enterprise, cloud areas, just like the robotics or smart manufacturing we are talking today, which is the trend of the growth for the next decade. Meanwhile, we also invest across the market where we see opportunity to grow and to develop in this world. And earlier this year, not sure if someone here remember, maybe February 1st, we announced to the market, we will increase our capital expenditure to 5 billion per year this year and next year through 2026. And people who knows the market situation of semiconductors this year might feel like the insanity why you are spending a lot of money today. But the fact is, if we don't do the right thing today, when we enable a new factory, the cycle time will need at least 3 years until it can deliver, right? So we continue investing in that, and actually we increased the capacity investment this year. We have 2 300mm wafer fab just launched in production end of last year. We have 3 more 12-inch wafer fab under construction right now, and we have another 2 12-inch wafer fab in planning. And that together, and all of those factories are for 45 nanometer to 130 nanometer, which is the process node we see with optimal cost, performance, power, voltage level to enable analog and embedded products. And put together those capacity investment we have today, the 7 fabs will give us to support our ambition to become a 45 billion revenue company in 2030. And the expansion cannot just be at the capacity, right? So we are expanding our foundation at technology and capabilities. With the process, package, design, testing, through all these effects to drive the innovation to enable a smarter, smaller, higher power efficiency and lower consumption and more affordable semiconductor. That is the things we are driving and developing. And with the capacity expansion as well, our goal is to build a flexible assurance of supply and time to market performance of our delivery and order fulfillment performance. And last but not least, the quality and cost. It's always, when we develop the technology, that is the things we need to continue increase the reliability, the quality, and also having semiconductor to be more affordable to the market. So today we talk about robotics and talk about smart manufacturing. And in fact, it's not a new thing in terms of robotics, right? 50 years ago, the first robotic has been in the world. And that robot is good enough, precise enough, performance well enough to help human beings to increase the efficiency running in a factory. but it is also dangerous, right? And so with the sensor technology, motor drive technology, as well as the computing technology evolve to enable the robots to be more collaborative. And recently, we also start to talk about AGV and AMR, which is with the increasing of the capability on sensing, on AI, on the edge computing, enabling these robots to be more smarter, right? And lastly, this innovation will not stop at the factory. The front door of factory, actually outside of factory, we already see these smarter and better robots to change our life. And we believe while this innovation continue to evolve, we don't even can imagine how this will continue to change our life in the next years. So there are 5 trends we are observing in this robotics development. The first is collaboration, how human can collaborate with robotics in the production line safely and efficiently. And the self-learning and autonomy, as again, it's driven by AI and edge computing, plus the computing capability we have evolved in the world. Safety is certainly a must in the trend, and energy efficiency with the development of the battery, the BMS, and the wireless connectivities, there is certainly a trend to continue to evolve. And last but not least, there is size and complexity and cost reduction. There is the critical area, critical points to really bring robotics to not only at the factory, but everywhere that can help the human being down the road. Right, so let me pause here. I will introduce Matthias, our expert of robotics from Germany, to give everybody a further talk on the trend of the technologies here.
My name is Matthias, and I'm working in TI in the so-called robotics systems engineering team. So TI itself, we are a semiconductor company, so we will not start to develop robots ourselves. But I want to talk a little bit about the products that TI develops that enable current robotics and then also the future of robotics. And I think a lot of the trends we heard earlier for self-driving cars, for autonomous vehicle, and also for energy efficiency are also similar to what we need for the next generation of robotics. So the first topic I want to talk about is collaboration, and especially safe collaboration between humans and robots. So I think we all imagine in the future, right? So the long-term case will be a factory where almost no human will be needed. But I think on the short term, the first step will be to humans work alongside with robots. And one key requirement for that is that it happens in a safe way and that it also happens in an efficient way. So one example that we have here for that is safe collaboration between humans and robots. And one challenge right now is for collaborative robots that they can work efficiently and with a high speed and close to humans. So one example that we have here is the sensor technology that we are using, a millimeter wave radar. So in the past, the first generation of robotics was surrounded by a cage, right? But the collaborative robot needs a human to come very close, and we enabled that with a millimeter wave radar. So what we do here is we create a safety bubble through radar next to the robot, and we define different zones in front of the robot. So you can see there's a safe area when the human is very far away from the robot, and when he walks closer, we can slow down the robot, and only when he's really close to the robot will actually stop. So this requires a very precise millimeter wave sensor, and it also requires a safe millimeter wave sensor. So maybe how do I go? Yeah. So one example we are using here is a TI radar sensor, and this sensor is also coming with antenna on package options. So that means it's also easier to deploy because the high frequency design doesn't have to be touched. So you can just have the antenna integrated. At the same time, the sensor is coming with safety certifications, and we are also running it on efficient processes so that it's coming at a lower cost in the future. And The good thing about radar technology, through the accuracy you can get out of a radar sensor, is also that you don't only detect if an object is coming closer, you can also differentiate what kind of object it is. So by running some algorithms on the radar sensor, you can differentiate if the object is, for example, a human or if it's another robot. And that means you can also increase the efficiency of your production because you don't slow down your process when another robot is coming close, but you just slow down the process when another human is getting into the area of the robot. Next to the sensing technology, so radar is just one example of that. Processing is also needed. So efficient computing at the place where the data is generated. So more new sensors also generate more data, and this data needs to be processed efficiently. So another big topic which also TI is focusing on is edge computing and AI computing. And all of that for robotics, again, it has to happen safely. That means the processes and the algorithms, but also the hardware and the system level hardware requires a certain level of functional safety. And the AI compute, we can already see today, has a lot of use cases for robotics. So one example we are showing here on the top is, for example, visual inspection. Right? We talked about car manufacturing earlier, and that these cars need to be manufactured in a very accurate and precise way. So also the inspection of the cars has to be done in a very precise way. So you can train robots with a vision extension in order to do the inspection of the car, and you can ensure with the robots that the quality of your manufacturing is at the right level. But it will not stop at just vision inspection. Of course, it will go beyond that. So robots will in the future be more and more able to perform tasks autonomously and on their own. And this will be similar like self-driving in the future, when an autonomous robot can also drive on its own. And all of that also requires a lot of processing power. The TI solution we are offering here, so we are showing an example of one of our edge processor families. So I think we hear a lot about these high performance edge processors, but there's also lower performances that need to be computed at a good or at an efficient power level and a good cost structure. So we are offering a scalable family of edge processors that also come with the right peripheral needs that are needed for connecting different kind of sensor types for the robotics. Another topic which is affecting robotics is energy efficiency. I think we talked about reducing the greenhouse emissions of the cars, right? It also means reducing the greenhouse emissions of the factory itself. And since more robots and more machinery is installed in factories, that means also these machineries need to reduce the energy consumption. So TI itself, for example, also tries to gradually reduce the amount of energy we use in our semiconductor manufacturing. And we also use a lot of robots. So getting more efficient robots will help us to decrease the energy usage of the manufacturing. Energy efficiency also, at the other hand, enables new types of robotics and also new architectures of robotics. So that means if a semiconductor can consume less power on the same size, or if I can reduce the size of my semiconductor package needing the same power, or if I can remove the heatsink, I can also build new architectures of robots or build my robots more efficiently. So one example we are showing here, so earlier we heard about IGBT and GaN, so also TI is investing into GaN technologies, and GaN can be used in different areas in robotics. So one is the inverter stage, so the motor. So in comparison to GaN, for example, to IGBTs, GaN can reduce the switching losses by 80%. At the same time, compared to a classic silicon MOSFET, you can get to half of the size with a GaN semiconductor. So this enables much smaller power stages for the robots, and for example, also as we can see here, for the collaborative robots, typically the power stage is within the joints of these robots. So there are motors in each joint, and also the power electronics is in the joints. And with technologies like GAN, heavier payload robots can build in this way, and also the cost of these robots can be reduced because the heatsink can get removed, or also the amount of weight the robot needs can be reduced. Power efficiency, of course, is also again on the computation side. So we talked about these AI models, and for the AI model you can run it either just on generic hardware, but there's also a specific hardware built to run AI efficiently. And we also integrate on these edge compute processors dedicated AI accelerators that can reduce the computing power and can increase the computing speed by the factor of 10. So another area where GAN can also be used is by regenerating the energy of the robot. So a robot is performing a lot of fast movements with a lot of starting and stopping. So with GAN you can also build bidirectional DC-DC converters. That means when I break the motor of the robot, it's similar like breaking the motor of a car, right? I get generative energy from the motor, and this energy I can also reuse and feed it back either into a big battery, or I can also feed it back into my energy grid. So I increase the power efficiency of the robotics itself. Another example is just overall reducing the cost and the complexity of robots. And I think with reducing the cost and the complexity of robots, so William already touched about the new applications that robots can do. And that means also making more things doable by robots, which means if the robot has a better cost structure, there are also more applications that I can automate with a robot. And maybe in the future, even if a robot comes at a good cost structure, I can also use it at my home. So one example how to reduce the cost of the robots is the communications. So within the robot, you have a lot of different motors that are moving. And in order to create a fine motion, these motors need to be synchronized in a timely manner. So there are communication protocols and physical communication layers like Ethernet, and this runs on wires. So one trend that TI is supporting, for example, is single pair Ethernet. And with single pair Ethernet, you can go down to reuse just 2 pairs of wires for the communication, but also for your power level. That means the robot that I was showing earlier with the different joints, in the future I can just use one pair of wires to let the power flow through the robot, but also let the communication flow through the robot. And that overall reduces the cost of robotics. Another topic, since now we have collaborative robots in the factories, we also want to install them into existing manufacturing flows. And existing manufacturing flows already have an existing protocol layer, an existing communication structure. So that means a robot needs to be able to plug into these communication structures and function or communicate with the factory grid. So that every factory grid often has a different communication structure. And one thing that we are offering is multi-protocol chips. So that means I can take the same solution and connect different protocol stacks to it. So that means I have a very flexible and cost-effective solution to connect my robot to different kind of factory structures and meet it at the right cost. These MCUs that I'm mentioning that have these multi-protocol layers, they still also have a lot of real-time functionalities equipped. So that means you can in the future use the same MCU to do real-time communication, but it also comes with peripherals that are needed to do the motor control. So that means you can reduce the amount of devices you need from, let's say, several different MCUs down to one single MCU that can do communication and the motor control. So that was different topics that I was touching about. So how TI can enable the next generation of robotics. And I think the future is just starting right now. So in the future, I think we will see a lot of more applications where robots are used, and also a lot of new innovative semiconductors that can be used to enable this next generation of robots. We have built a little demo also to show how the millimeter wave and how one edge processor running in an AI model is working. So we are working with our partner Techman Robot, and we are showcasing this also at the booth from Techman. So the L618 is the location. So I also invite you to come there over the next days and just have a look at it and discuss with us on how this can automate your application. So with that, thanks a lot for the attention, and yeah,